Buongiorno a tutti e benvenuti a questo secondo OCRIM webinar dedicato alla gestione e alla manutenzione per un corretto funzionamento dei macchinari ad uso molitorio. Quindi è il secondo webinar della rassegna Automation and Maintenance. Vi ringrazio innanzitutto per esservi iscritti e per essere presenti oggi.
Thank you for following us remotely. Now, this event is held in Italian, but you can take advantage of the simultaneous translation. You can choose the interpretation menu on the bottom right of your screen. You can choose the language you want. So the simultaneous translation into English. We need to thank Maurizio Boni for English, Riccardo Pella for French, and Stefania Lama for Spanish. Thank you so much. I really would like to thank the translators. Thank you for inviting us. Okay, then, without further ado, I'd like to introduce the topic today, which is stone milling. Now, we will be talking about today's protagonist, the Biostone mill that you can see here behind me. We will also be talking about the benefits, the advantages, the technical, mechanical aspects concerning the maintenance and the main features of this machine. We will also be talking about the technological aspects of the machine from the product point of view, which is what you can get thanks to stone milling. Okay, without further ado, I'd like to invite Simona Di Giorni. Simona, thank you for being here today. Thank you, Nicola. Good afternoon, everyone. Simona is a biotechnologist. She works in our biotechnology department. So once again, technology and engineering service. I mean, she will help us understand the technological aspects from the product perspective. I also would like to invite Simone Montanari. Good afternoon, everyone. So Simone works in our sister company, Pagliarani. So Simone is one of the main designers of a Biostone mill that you can see here today. My name is Nicola Riboldi. Maybe you have participated in the first webinar. I am a mechanical engineer here in OCRIM. I've been doing this for 3 years. I work at the canal, so at the port here in Cremone, and I basically design OCRIM machines. At the end of our presentations, you can use the chat and you can send us questions and doubts if you have any. You can also send us further questions or doubts. Maybe today's explanations won't be complete for you, so don't hesitate to ask any kind of question. I'd like to ask Simona to comply with social distancing because of the COVID situation here in the city. So without further ado, I have the first question to Simone, a general introduction and sort of, a track record of the Biostone mill. Good afternoon, everyone. My name is Simone Montanari, and I am in the team of designers who designed and made and also installed many Biostone mill machines at our customers. This project was born in 2015 thanks to the synergy between the two companies, OCRIM and Pagliarani. On the one side, the experience in building milling machines. On the other side, the possibility to build machines having a high technological content. So OCRIM and Pagliarani merged. They are now working together. And now we have made a stone mill 100% made in Italy. So this can be used for the large OCRIM installations or equipment, but also many small milling companies in Italy and in the world, including very small farms. I mean, those companies that, had nothing to do with industrial milling. Thank you for the introduction. Would like now to give you, ask you the first question. So, what are the main objectives of Biostonemill? Now, at the beginning of this adventure, we set 4 targets. First of all, having a very efficient product from the milling point of view, making a machine, as automatic as possible, avoiding the hard work of, reshaping the stone, and having a beautiful aspect or look in compliance with the tradition of this machine.
Grazie. E quindi gli obiettivi che ci hai appena elencato immagino che siano comunque nati.
Thank you. Well, I think that, these objectives are based on an in-depth market research, right? Yes, there's been a long, in-depth market research. So we have focused on some key points. For example, the frame made in wood, like so many years ago. Joints are made in aluminum. This is to guarantee stability to the machine and absorb the vibration of the rotating stone. The weight is 900 kilos, up to 150 revs a minute. There's a dormant lower stone, while the upper stone is rotating and oscillating. So once again, this part is made in stainless steel in order to have the right sanitation. Last but not least, we have the automatic system that is one of the key features of the machine. You can see here the result. This is the big size, and this is the 1,500 millimeters. This is the diameter. And you are now referring to the heart of the machine, which are the stones. So I'd like to talk about this aspect, so the stones. And in this case, you can see the upper stone. Now, as for the stones, this was a key focus for us, and it represents the beating heart of the machine. It has an impact on the quality of the milled product. Now, we wanted to change La Ferté, which is the French stone. So now we have an agglomerated system. So it's a stone made of different grains, if you will, put together. So it is an agglomerated product with food grade certificate. The result was highly satisfactory. We have a large size stone, very hard, very compact, limited porosity. You can see here radial grooves, which are very accurate. This means we can mill from 250 to 500 kilos of product per hour. The output temperature is less than 40 degrees centigrade. This is really important to keep all of these features, the features of the grain, unchanged. As for reshaping, what can you tell us? I can read the technical definition of reshaping. It means, once again, renovating or reshaping the grooves because of, there's wear and tear in contact with the milled product. So with this kind of stone, this kind of technology is an old memory because these stones are reshaping. And the electronic control doesn't allow the stones to rub if there's no product. So this is what didn't happen in the ancient stone mills. So long life cycle of the stones and a minimum level of maintenance downtime. So you are showing us the control panel. So can I ask you to give us insights on the control and the automation of the machine? Now, as for the automation, well, this is the real big difference versus the other machines we are marketing. This machine complies with Industry 4.0. All of the milling parameters are managed by a touch screen interface, very user-friendly. Also, the non-technicians are able to use it. It is possible to recall and store specific recipes. For example, you have to mill different types of products. So this is a digitization process. It simplifies the work of the miller. So you know, he or she can count on a specific control tool during the milling process.
Grazie mille. Ti chiedo velocemente di
Thank
elencare
you.
quali
Can you
sono
name quickly
appunto i prodotti che
the
possono essere
products
implementati
that may be well processed in our Biostone mill? I'll be very quick, but of course I will then give the floor to Mrs. Dijuni. We can have soft and hard wheat, oats, barley, spelt, maize, chickpeas, millet, kamut, coriander, rice, and rye.
e analizziamo a questo punto
Thank you. Well, I think now we can analyze the features of the main, well, components of the Biostone mill. Starting from the very top, I can see that the machine comes, for example, with a feeding screw, and on the top of the machine, right on the lid, you can see here the feeding screw. It is 100% made in stainless steel. It has an inspection window so that you can see the flow of the product. You can see here the gear motor controlled by an inverter to ensure a smooth, consistent grain inlet. 120 millimeter standard inlet, and the coupling is by means of coupling sleeves. A couple of words on the lid. Yes, the lid is made of wood in fir, anti-UV treated, split into 3 parts. The central part accommodates the screw and it's fixed. The 2 side crescents can be removed so that you can clean the milling chamber. We have a dust-proof seal so that you don't have any waste of milled product. So once again, let's move downwards. I think you now have the so-called drum, right? Yes, the drum. The drum is a real container of the milled product. The frame is in aluminum. Inside we have stainless steel. So when you have contact of the flour, the external part is coated with stoneware, treated with antimicrobial system. And at the center, we have once again a double chamber window, which gives you the possibility to see what happens inside. You can see the product being milled. Thank you. Perfect. So inside the drum, we don't see it here, by the way, but we find the upper wheel or stone that we can see here. Okay, can we have just a short explanation of this? Yes, it is here on the ground. So this is the upper wheel. It rotates and oscillates. And right at the center, we have a 2-axle, let's say, bell. So it can be stabilized and stay flat during the process. Depending on the flow of product it is milling. You have just talked about the flow of product. So when the product gets in, how is it distributed on the wheels? So the product comes out of the screw and then free falling, so the tangential speed is equal to 0. We need a distributor, a very small component. If you don't have this, all the wheat would stay at the center of the wheel. This distributor distributes consistently the cereal or the grains on the surface of the wheel, so we have a steady size all over the surface of the wheel. Thank you. So unlike the upper wheel, we can see, well, of course it is inside the drum, we can see the lower wheel, right? Yes. So we have used the same material, same hardness. It is fixed, it is supported by onto the frame in 4 different points. It accommodates the bases, if you will, where you can see the flour outlets or the grain outlets. You don't see it here because they are on the back of the machine. So we have 2 outlets. Yeah. The first one for lab samples, the second one for the pneumatic line, so that the product can move to the following steps. Thank you. All the elements we have explained so far are based on the frame of the machine, right? Yes, the frame is, well, something we really strove to design. So we have strong lamella wood, Italian wood. We have joints in aluminum from the billet with 5-axis machines. Now, this gives top solidity and sturdiness of the structure, and it avoids the typical oscillation of the machine. Now, the weight is 900 kilos. It rotates, so of course it generates oscillations. So thanks to the frame, we absorb the vibration, right? As for the sensors or the probes, or sensors, we have basically two. The first one is the product failure sensor. It is usually onto the loading hopper connected to the feed screw. The second one is located into an outlet. It is a temperature probe. This helps the miller because we understand in real time what the outlet temperature of the grain is. As a consequence, he or she can adjust the parameters of the machine thanks to the touchscreen, so you may want to change the position of the wheels. Thank you so much for your explanation. But I think that now we made a list, of the objectives. We talked about the history of the machine and even the design of the machine. So, well, I think that these are the key aspects, characterizing every single element of the machine. Well, I think that what is really interesting for the, let's say, people, I think you can really, share with us a practical hands-on demo so we can switch on the machine and see how it works. Once again, there's a hopper and a sensor of, let's say, product failure sensor. It's a very important sensor. In a minute, I will tell you why. So right now, the two wheels are dormant, so they are idle. The mill is ready to start. There's an automatic cycle ready. So just push. So you just have to click on one button, and you can see the gap between the two wheels up to 3 millimeters. They start rotating, reaching the speed you want. In this case, I have set 100 revs a minute. So once they reach 100, they will go back to the so-called milling gap. Usually the gap goes from 0.6 millimeters to 0.05 millimeters. The screw will start its operation and the product will reach the central part of the stone mill. It will be crushed, it will become finer and finer, smaller and smaller. It will then be aspirated by the suction circuit. We have two possible events. So the miller has finished with the operation. You can click on End. The product doesn't flow into the machine any longer. The wheels slow down and then they go back to gap 0. Or the product failure sensor detects the lack of cereal or grain and it stops milling. The two stones don't rub against each other, so no rubbing between the upper and the lower wheel. Thank you. Thank you. Interesting demo. Thank you. Okay, I think we can now talk about the maintenance of Biostonemill. So, which are the operations required in order to have the right conditions for the Biostonemill? Well, as for the maintenance of the machine, I have to say it's quite simple and limited, so to say. These operations do not require the presence of an experienced, skilled technician. They can be carried out directly by the end user of the machine. Now, the end user, of course, has to be trained. So we offer an accurate training at the end of every single installation. We have 3 greasing points. As for the, let's say, timeline, well, there's a pop-up that appears on the touch screen. Now, the key point is the following. Well, just like every single machine, also the machines of the past, you have to sanitize, to clean the wheels. It's a problem to remove, the wheel. It's difficult, it's heavy, and even dangerous. So, thanks to a specific manual function, the two stones reach a 60-millimeter gap. This means that a person will be able to use a specific rotating tool, so an operator can clean the grooves on the stone that may be, residues of product. Now, these maintenance processes have been planned to be performed by one single operator. Sometimes in small firms or small farms, these machines are used in small rooms, for example, the miller, the maintenance person, and then the person taking care of load and unload. It's the same person. Okay, so I understand the machine is really user-friendly. It absolutely is. Before inviting Simona, she will be talking about, let's say, the technology of this machine. I have a very last question for you. Can you tell us in which contexts Biostonemill can be used? I have to say that, well, we have received many orders, and I have to say that we have installed them in many different contexts. For example, a small mill, so in this case we have the mill and the tumbler. We also have some complete systems, so load, de-hulling, and then sieving, all the way to the traditional large-size Okrim milling center, in order to have the so-called B1, followed by the traditional system with cylinders. Thank you so much for your intervention and your very specific information. Thank you so much once again. I'm now inviting Simona. Okay. Thank you, Simona. I'll see you later. Okay, Simona. Now, Simona will be talking about stone milling, and let's say she will share with us the technological point. Okay? Now, to explain the functioning, so the operation and even the main features of stone milling, my example would be wheat milling, and in particular, the comparison between wheat stone milling and the so-called traditional industrial milling with cylinders. So in the case of the stone mill, now when the wheat gets into the machine thanks to the screw, so it is in contact with the stone, let's say that there are two mechanical actions that take place. The first one is crushing. So basically, the wheat grain has to go through the two wheels with a specific gap. In some cases, the gap is very small, 0.05 millimeters, for example. So we crush the grain. The second action that is carried out is the abrasion. So this is basically the wrapping or the contact between the grain and the stone. This is why we create fine particles or flour. So the abrasive process will start from the external parts of the grain. So what is the external part of the wheat grain? We have the bran. The bran, is all around the grain. We have the germ, which is so externally on the one side. So the internal part is the endosperm of the grain. So it will have a lower level of abrasion. So the consequence of the external part abrasion allows us to have bran and germ to be milled with very small sizes. And this is why we find them in the final product, so in the flour generated by the stone mill. Now, we can say that the stone milling includes the milling of the entire grain. So the final product or end product will be formed by three key components of the wheat in this case. What happens in a roller or cylinder milling? In this case, the grain is crushed between the two different rollers moving, but of course there is no abrasion. Of course, it all depends on the rotation of the rollers or cylinders. This means that we have other forces, for example, traction forces. Now, these traction forces do not reduce the bran or the germ in very small sizes. Well, right the opposite. I mean, the size is bigger because, of course, these tissues are much more, if you will, elastic versus the internal endosperm. So this behavioral difference of the various, tissues, if you will, in terms of cylinder or roller milling, gives us the opportunity to separate the three components I have just mentioned. So in the industrial milling, we have the separation of the bran, then the separation of the germ, and finally the separation of the internal part, the endosperm, which is represented by starch and proteins. So if we check, the end products, and if you make a comparison, cylinder milling and stone milling, well, the end products are totally different from the making point of view. So in the first case, we have the whole entire grain. Let's say that it is just, smaller. In the second case, we have a separation of the three components. Now, this means that from the nutritional point of view, the flours obtained by the two processes are totally different. The, let's say, stone flour will contain more fibers, which are contained in the bran, but also mineral salts and proteins, which are contained in the external layer, enzymes, vitamins that you find in the germ, and fats. So this is a more complete nutritional profile versus the industrial flour, which is basically the internal part of the grain. So once again, as we said before, starch and proteins. Now, on the other side, this kind of stone flour contains all of these components. Well, this means that the stone milled flour lasts for a smaller time, so the shelf life is shorter. Once again, in this case, shelf life is shorter for stone milled products versus cylinder or industrial milled products. There's another difference, which is due to the different milling technology. I'm talking about the size. So what do we mean by this? Well, the stone mill basically mills in just one single pass or step. The end product will contain very small sizes, very small particles, but also large particles. I mean, the range is very wide. The second process, let's say the sieving and separation process, allows you to choose in, let's say, into a size range, but the size of the product will be bigger than the size you obtain with cylinder milling. So why does this happen? Well, because the cylinder milling takes place in different steps, between 10 and 15 different steps. In every single milling step, there's a sort of a selection of size of the inlet product. Now, this means that in general, we reduce, the size, so we have a smaller and smaller size of the particles. So as a consequence, there's another difference, between the product, stone milling and cylinder milling. So another difference, as you have understood, is the size of the particles. So this is from the point of view of the use of the final, of the end product. So what is the consequence of this? Well, we have two key consequences, in my opinion. On the one side, the various different water absorption. In stone milled flour, we have more bran, more proteins, which are contained in the endosperm, and not only, we have vitamins, as I said before, we have mineral salts, and so all of these compounds or chemical components absorb water. As a consequence, when you mill the same variety of mill, but when we use the stone instead of cylinder, well, we have a different behavior. This is a very important aspect because it concerns water absorption. The second point is the size, as I said before. So, because in this case we have larger products, or anyway, the size is different versus what we are used to with industrial flours, I have to say that the mix processes, but also the yeast and all of the processes, I mean, of the uses of the end products, well, they will have different timing because the particles are bigger and of course that they need more time to form the final mix. So, to conclude, I mean, as for the wheat milling, we can say that the stone milling and the cylinder milling generate two totally different products. This is the reason why we, if you will, went back to the past. So we are using a technology that was used in the past, you know, because in the past decades, we have understood that it is really very important, I mean, to comply with the nutritional features of food. So we decided, I mean, to go back to a product which is more comprehensive. But of course, it has to be adjusted and it has to fit the current production systems, which are now based on the use of industrial flours. I would like now to draw your attention on the use of the machine inside the process, because as my colleague said before, the machine can be used as a standalone object. So you have stone milling and the tumbler, so the sieve, in order to do a selection of the milled product. It can also be used in a different context, for example, in a complete system. When I say complete, I mean upstream. So in terms of sanitation, cleaning, and preparation of wheat before milling. So I'm sure you understand that, you know, stone milling happens in just one step. So what we obtain at the end depends on what we used at the beginning. So in order to obtain a safe product, especially in terms of, you know, safety or presence of microorganisms or foreign bodies, what is fundamental is the right sanitation, so the right cleaning. It has to be as accurate as possible, and it has to be a top-notch, top-quality action. It is interesting to clean or sanitize the external parts of the grain. I mean, a bran is represented by different layers, and the nutritional layers, I mean, the most interesting one is the internal layer, so the layer which is closest to the endosperm. The external layer is basically represented by bran or fiber. So if you remove the first or the second layer, well, what happens is that you can really remove the skin, if you will, of the grain. So we remove what you can find on the surface. And on the surface, we can find bacteria, molds, and sometimes chemical substances that have been used in the field or into the wheat production process. As a consequence, we have a small, light dehulling of the grain. It means that the final end product will have a much better sanitation quality. A partial dehulling of the grain also allows to lower the content of mineral salts, for example, ashes. So back to cleaning or sanitation, as we usually say. Another process which is able to improve or to help stone milling is wetting. So just like cylinder milling, I have to say that wetting gives us the possibility to soften, if you will, the grain. So we reduce its hardness. And again, this means that milling is easier. We will have a smaller, finer product. There's a disadvantage or a drawback. If you wet the products, well, the products will increase the humidity level, and if the cleaning process is not accurate, we may see the formation of contaminations or mold inside the system. Let's say that the wetting system may be used on stone milling as well. It is not essential, if you will, because, quite often in most systems, wetting has not been used. So basically we have dry milled. But, depending on the end product we want to obtain, you can also, well, you may want to add the wetting phase, provided that you know one important thing. If you don't handle the equipment in the right way, you may raise problems in terms of contamination. Last but not least, let me show you the downstream part. So it is represented by a sieve or tumbler in order to select the right size. There's nothing more than this. I mean, we don't need any other systems in particular, because the product basically is a whole product. It is complete. So no, for example, brand cleaning or removal. So I have used a wheel as an example, but this machine can also be used for other grains or cereals like maize. You have to consider that stone milled maize flour will have a high content in fat because of the germ, so it is 20%, just the germ. So this product is totally different versus what we are used to do or to have in industrial milling. It can be used for pulses, so for chickpeas and then peas, lentils. What is really important is to use products that don't have to have a high content in fat, for example, walnuts, nuts, and flax seeds. Because, I mean, if you use products with a very high content of fat, you don't crush the grains. I mean, what you see is a sort of a mix, a blend. You don't obtain flour, but you obtain a sort of a paste that you cannot even use. Okay, this is it with my presentation. Now, if you have doubts or questions, please do not hesitate, and we will answer all your questions. So thank you, Simona. So, as you said before, you can send us questions in our chat, so questions and or doubts. So Simona now will reply your questions with Mr. Simone Montanari. So both will be able to take questions and answer them. The Q&A session, of course, will be translated into English, French, and Spanish. So we would like once again to thank Maurizio, Riccardo, and Stefania. Well, thank you. Okay, so just waiting for some questions. Okay, here's the first one. Let me check. Okay, I think both can answer, so depending on your opinion. So how can we solve the problems having to do with condensation water and high temperature? Thank you for the question. Well, as far as I am concerned, the suction or aspiration system of the Biostonemill keeps the machine clean. So we had a very good, if you will, reaction of the machine. As for the high temperatures, no, we have never seen them or reached them. For example, in all of my tests, I have never reached more than 40 degrees. Well, in terms of safety, we know that the machine comes with temperature probe that you can set. So it's always around 40 degrees, okay, independent from the grain. Of course, we have to have ambient temperature for the inlet or incoming cereal. Thank you. So we now can take another question. Now, because the milling step is one and one only, how can we manage ashes? Well, it all depends on the incoming product. I mean, if there's low ashes in this product, you will have low ashes in the final product. If you have, for example, grains, incoming grains, which is what we saw in the past months, where the so-called ancient grains here in Italy, well, the ashes content is sometimes more than 2%. So in that case, it is really difficult, I mean, to have a final product with low ashes content. We can use de-hulling. This means we can, remove a part of the bran, as I said before, especially the most external layers. Let's say from the nutritional point of view, they contain fibers only. So we keep the germ. We will remove the most external part. And of course, we are able to reduce the percent of ashes. So we can do this. And if this is not enough, we can also use wetting, as I said before, because wetting, just like cylinder milling, increases the elasticity of bran. The abrasive action of the stones on the bran is smaller. So in the stone mill, bran would form large-size particles. These particles may be removed in the following step, which is sieving or tumbling. Thank you, Simona. Now, there's a question I can see here. The wear and tear of the stones, Simona. Simona, what can you tell us about this? Well, I have to say that in the various situations, we have never, offered, let's say, spare stones. I have to say that we have machines milling more than 3,000 tons of wheat, and the wear and tear was less than 1/10 of a millimeter. And I can't say they will last forever, but almost. So you don't have to have spare stones, of course. I mean, removing a stone would be quite difficult. Yes, it's difficult. I mean, it's very heavy. So thanks to the hardness and no wear and tear, it is possible to operate the machine with a high level of effectiveness and efficiency.
Ok, invece a Simona mi chiedono, posso
Now,
fare
Simona,
farina di
this is
glutine?
the question for you. Can I have soft wheat flours? Yes.
Nello specifico con questa macchina,
Okay, I mean with this machine. Yes, absolutely. I mean the soft wheat flour. Yes, if you use I mean soft wheat, of course, you can have soft wheat flour. What you obtain is a wholemeal flour, so it includes bran and germ. It is a complete, if you will, flour, much richer from the nutritional point of view and different than the whole meal flour, which is produced with cylinder milling. So we saw that with stone milling automatically, we have a complete milling of the grain. And as for the cylinder, we have to reassemble. So flour and bran are put together. So once again, in this case, we have basically no germ. Flour can be stored for a shorter time, so usually it is not used. As a consequence, I mean, the two whole meal flours, I mean, stone and industrial, have a difference. Thank you. Let me go back to suction or the aspiration system. What can we say about this? So if the machine is connected to the suction system, what is the technological consequence? Now, aspiration system here is compulsory. So apart from the parameters, we have to adjust the aspiration. So if you have more or less suction, you can change the features of the milled product. So it is a very important aspect that has to be calculated very well in every single system, depending on what you want to obtain, and especially depending on the capacities you want.
Simona, tu vuoi aggiungere qualcosa?
So in terms of using the machine, I saw that the aspiration, I mean, of the stone miller, when you have a changeover, so when you change the variety or you change the types of wheat, for example, soft wheat or even durum wheat, this means that the changeover time is short because there's a self-cleaning, a self-sanitation system of the machine. So this means that you can move, you know, from a specific setup, or you can do the changeover very quickly and in no time. So there's a deep, thorough sanitation. When we totally change the type of grain, you have to pay attention, of course. For example, if you want to have some specific milling on specific wheat to produce flours for celiacs, the aspiration system is very good, cleaning is very good, but it's always a good idea to have a dedicated line for example, products for the celiacs. So it is recommended not to do too much mixing. There's another question. A piece, a metal part may not have been seen, so what may happen to the stones in this case? Yes, it happened. and it happened that a very small metal fragment has been, captured by the magnet. Then it came off the magnet, and then it got into the mill. So it was a surprise for us, but at the same time, we were very happy. Stones haven't been damaged. No abrasion, no damage whatsoever. Well, the metal piece was damaged, so the machine is reliable. Exactly. Don't forget that at the inlet of the machine, but also in the outlet, we have magnets. So even if something is, let's say, milled by the machine, anyway, this residue is captured by the downstream magnet. So you don't damage the wheels, but at the same time, you won't find any metal residue in the final end product. We understood what was happening because the machine identified something weird. We understood this because we saw the piece into the magnet. And we said, well, where does this fragment come from? Well, it went through, in the gap between the two wheels. Okay, then I think now we can have a couple of final questions. What is the difference between stone milling, so whole meal flour obtained with stone milling versus the industrial milled flour? Thank you. Well, as I said before, the difference is that, in the stone milling, we have just one step. So one step to mill the entire grain. In the industrial milling, the components, the endosperm, the bran, of course, are sort of, separated. And then at the end, we put together, the flour, the endosperm, and the bran. The main difference that you can see checking the two types of flours is that the bran in the industrial flour is calibrated. So more or less it falls within the same size range. In the stone mill flour, we have many different sizes, from very small particles, less than 180 microns, which is the ordinary flour, to bigger particles. So from the technological point of view, this is the main difference. A question for Simone. What is the installed power of this machine? Main motor that operates the upper wheel is 15 kilowatts. Of course, there's a reduction system so as to reach a maximum of 150 revs a minute. Okay, very last question. So, the question is on the temperature and temperature control. We have already talked about this, during the webinar. Maybe some more information about the outlet temperature. Please consider that the stone mills have an abrasive effect. So you may think that the temperature of the flour increases because we know very well that if you rub your hands, for example, abrasion increases temperature. I have to say that in all the tests that we have carried out, considering the operating conditions of the machine, and with a specific number of revolutions from 100 to 120, maximum 130, so the distance between the two wheels is 0.05 millimeters. The maximum temperature was 40 degrees. So the main biological molecules, for example, proteins or even enzymes, but also vitamins, with that temperature, there is no damage, no impact on those ingredients or substances. So I have to say that we have never had any problem in terms of high temperature. Simone, maybe you want to add something? Yes. The situation is very different, by the way, we understood during the market survey on the small size mills. For example, the 800 millimeter mill, especially those with, you know, the fixed wheel on the top and the rotating wheel on the bottom. Even if you pay attention, the flour can also be 70 degrees. I mean, it is really hot. So this is why we decided to have a heavy, big size machine, but it works in a very specific way, keeping the temperature low. Okay, then, thank you so much. I think, well, I'm now inviting you to join me here so that we can close the event. So, perfect timing. I really would like to thank you. Thank you so much for your specific, insightful presentations. Very interesting, I have to say. And let me remind you that the recording of the event will be sent to everyone by email. It will also be available onto the Ocrim Vimeo channel. Once again, I would like to thank the three interpreters. Once again, Maurizio for English, thank you so much. Riccardo for French and Stefania for Spanish. I also would like to tell you that if you have further questions, please send them to conferenceroom@ocrim.com. Okay, the event is now over. Don't forget that at the end of your connection, so when you disconnect, please do fill in the questionnaire so that we can have your input and your feedback we needed to improve the next webinars. Next webinar will concern the flour mixing system. So we will be talking about macro and micro ingredients. And of course, we will also take into account, let's say, the most technological, most technical, presentation that we had some time ago. The protagonist will be Fabio Vuoto. Once again, thank you so much for spending 60 minutes with us. So hopefully we will see you in the next webinar here in Ocrim. Thank you so much. Bye-bye. Grazie.